Hello and welcome everyone. Today's question is Geek and its game of coins. So Geek and his friend is playing a game where we have n coins, and if Geek pick the last coin, then we have to return 1. If his friend pick the last coin, then we have to return 0. So we have to find whether Geek can win this game or not. So from n coins, he can pick x coins, y coins, or only one coin. So he has three options. So suppose we have 0 coins. So Geek cannot win because there is no coin. So Geek cannot win this game. If we have only one coin, then Geek will pick this coin, and so this is the last coin. So Geek wins. If we have two coins and Geek return, and Geek cannot pick three coins, four coins. So Geek have to pick one coin, and his friend turn. Now his friend cannot pick 3 coin, 4 coin, and he has to pick 1 coin. Now coins become 0. Now as you can see, from 2 coins, Geek cannot win. So we have reached 1 coin with its friend turn. So friend, we want his friend to fail. So we have to check. From 2, we have to check. From 1, whether we have 1 or 0. If we have 0, only then Geek can win. So I know it's kind of tricky, but after that you will get it. So we have to check whether from all the three options, 3, 4 or 1, we have 1 or 0. We only care about 0, and if we have 0, only then Geek can win, because on the next turn his friend loses the game. So from 2 coins, Geek cannot win, so we have to return 0. Now let's move to 3 coins. From 3 coins, Geek will pick 3 coin. So now coins become 0. So Geek wins. Now from 3 options, we have to check. If we pick 3 coin, then we have reached 0 coins. Then from 0, there is no coin available, and we have 0. Means Geek loses. So on the first turn, if we pick 3 coin, then we can win this game, and on the next step, other player loses the game. So here Geek wins. Now let's jump to next value. Value is 4. So we have three options, whether we can pick 3 coin, and on the next iteration, next player wins the game, and next player is his friend, and we don't want his friend to win. Now let's pick 4 coins, and the next player loses the game, and we want that. So in the 4 coins, Geek wins the game, so we'll place 1 here. Now we have to check for 5 coins. So we will move till 5. Now check. If we pick 3 coins, then we reach here, and the next player loses the game, and we want that. So Geek wins the game. So that's the overall approach. We have to check from n. So this is I, and this is our DP array. So we have to store the values on every iteration. So from current index, from I index, we have to check whether I minus x is possible, I minus y is possible, and I minus 1 is possible. And if that is possible and DP stores 0, means the next iteration, player loses, and on the current iteration, player wins. If that is possible, that means Geek wins at the ith step. So let's jump to code. So we will make DP array, and on the zeroth index, Geek cannot win, so we will place 0. And on the first index, DP pick 1 coin, and Geek wins. And now we iterate the loop from 2 to n. If I minus 1 is possible and DP of I minus 1 is 0, means the next player loses the game, so ith player wins the game. Same as it is with I minus x and I minus y. If I minus y is 0, means next player, next iteration, the geek or his friend loses the game, and on the ith iteration, geek wins the game. So at the end, we have to return. So else condition, we have missed the else condition. If so, we can avoid the else condition because default value of dp of array is 0. So we can avoid that. So we only care about the one. We only care about the winning position. So whether geek win or not. So at the end, we have to return dp of n. So that's the overall approach. Its time complexity is order of n, and its space complexity is order of n. I hope you understood the approach. If you still have any doubts, feel free to ask in the comment section. Thank you all for watching this video.